In this video, we will look at a couple examples from MGF 1107, section 4.4, when we are multiplying in bases other than 10. So in the first example, we are multiplying 445 base 8 times 2 in base 8. One thing to remember that if you are in base 8, we have 8 numerals, and the 8 numerals that are used in base 8 would be 0 through 7. So 0, 1, 2, 3, 4, 5, 6, 7. Another important thing to remember that in base 8, the place values are powers of 8. So we have the ones digit to the right, and then the eights, and then the 8 squareds, which would be 64, and then the 8 to the thirds, and so on. So it's the ones, the 8s to the first, the 8s to the seconds, the 8s to the third, and the 8s to the fourth, which hopefully we don't need those. So when we multiply, it's usually best just to multiply in base 10. So 2 times 5 is 10 in base 10. But since we're in base 8, we have to say, well, how many groups of 8 is that? And how many ones do we have left over? Well, 8 goes into 10 one time, and then we would have 2 left over, and that would be in base 8. So since we can't write both those numerals down, or digits down, we write the rightmost digit down, and we carry the left digit. And so then we have 2 times 4, which is 8, plus that 1, which is 9. So again, that's 9 in base 10. But that in base 8 would be one group of 8, because 8 goes into 9 one time with a remainder of 1. So it's 1, 1 in base 8. So how we write 9 is 9, but in base 8 it would be 1, 1. So again, we write down the right-hand digit, that's a 1, and we carry the left-hand digit, which is the other 1. So we have 2 times 4 is 8 again, plus that 1 is 9. So we just got done saying that 9 in base 10 is one group of 8 and 1, 1. So remember the place values. We have the ones on the right, and then to the left of that is how many groups of 8 do you have. So 9 is one group of 8 with 1, 1. So we just write that down. So our answer would be 1, 1, 1, 2 in base 8. The next problem we'll look at will be a little bit more challenging because it's in base 12. Now in base 12, the numerals that we will use will be symbols or numerals from 0 through 11. So again, there will be 12 numerals. So I'll write them down. The numerals that are allowed would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 and 11. But when we have numerals, we don't want them to take up 2 characters, so we use capital letters. We use A for 1, 0, which is like 10, and B for 1, 1, which is 11. So those are the numerals that we're going to be using. There are 12 of them. Now, when we multiply, we generally multiply in base 10, take the results, and convert those to base 12. Now, since we are in base 12, the position values to the right would be the ones. To the left of that will be the 12 to the first, which are just the 12s. To the left of that is 12 squared, which is 144. So again, it's the ones always over on the right hand side, and then the base to the first power, the base to the second power, so on as you go to the left. So when we first begin multiplying this problem, we want to go 3 times 8 as we would in base 10. 3 times 8 is 24. So in base 10, that's how we write 24. We say it's 2 groups of 10 and 4 ones. But we have to convert that to base 12. Now remember, in base 12, we have the ones digit on the right and the 12s digit on the left. So if we have 24, we want to say, well, how many groups of 12? We know we don't have any groups of 144 because 144 is larger than 24. So we don't need that third place value. We need the 12s and the 1s. So 12 divides into 24 2 times with a remainder of 0. And that kind of makes sense, because if you have 2 12s and 0 1s, that is 24. So again, we write down the 1s digit, and we carry the, in this case, not the 10s digit, but the 12s digit. We carry the 2. And then we go 3 times 2 is 6, plus 2 is 8. So 8 in base 10 is just 0 12s and 8 1s in base 12. So that's the same. 3 times 2 is 6, plus 2 is 8. Just 8 1s. Nothing to carry. 3 times b. Well, recall b is kind of like the, you can think of it as the 11. So 3 times 11 would be 33 in base 10. That means 3 10s and 3 1s, which we say is 33. And if we're converting that to base 12, again, we don't need any groups of 144. We want to know how many groups of 12 we have and how many 1s we have. So you start off with the largest place value, the 12. Say how many 12s go into 33. You have 2 groups of 12. 2 times 12 is 24. The remainder would be 9. So we'll write that as 2, 9. Then we move over a space when we multiply. So I'll put a 0 there, move over a space, and multiply much the same way. So now it's the 9. 9 times 8. In base 10, 9 times 8 is 72. Again, we don't need the 144s, but we need 12s and 1s. So if we have 72, 12 goes into 72 an even 6 times with a remainder of 0. So we write the 0 down from the 6 0, and we carry the 6. 9 times 2 is 18, plus that 6 is 24. I believe earlier we said 24 in base 10 would be 2 groups of 12 and 0 1s. So write down the 0 and carry the 2. 9 times b is 99, plus 2 is 101 in base 10. We still don't need the 144, but we need groups of 12 and groups of 1. So 12 goes into 101, I believe, 8 times, gives you 96. 8 times 12 is 96, and we have 5 1s left over. So we put a 5 there and an 8 there. Now we add. Now just remember, these numbers are in base 12. So if we add and we get a 12 or higher, we have to carry a group of 12 to the next column. So 0 plus 0 would be 0. 8 plus 0 is 8. 9 plus 0 is 9. 2 plus 5 is 7. And 8 plus nothing above it would just be 8. And that is in base 12. And that would be your answer in base 12. So these are 2 examples of multiplying in other bases. One was smaller than 10, and this example was a base that was larger than 10.